Yeah, hey everyone. It's my great pleasure to be speaking here. Um, I think LedgerFest is one of the best crypto events in town. I work here in, I think early this year's line hack. It's all the amazing events that brought by Columbia blockchain. Yeah, let's get started. So today I'm going to present Poseidon Lab, and our mission is to bring privacy to Web3. First, let me give you a little bit of introduction about us. So we are Poseidon Labs. The mission here is to bring privacy to every Web3 project. And my name is Shumo. I'm the co-founder of Poseidon Labs. We have several projects. So first, we have a Manta network and a Calamari network deployed as a parachain to Polkadot and Kusama relay chain. And we also have Poseidon VM as a research. And I will cover all of this during today's talk. And also, last but not the least important, we're actually in town. And we have an office at Long Island City. Please visit us and drop me messages after the talk. First, right, like why privacy? So I will just give my personal take, right? So as a history nerd, if you look at history, right, I think everyone should know this great man, the great thinker, John Locke. He basically is brought the idea of the right to property, right? So if you think about that, the right to property is not something objective or natural. It's some human concept and human creation, right? And thanks to John Locke and many, many great thinkers of his time, and we bring the right of property to this human society, and then I will say this triggers the entire age of enlightenment and also brought a great advance in human civilization, right? So here I claim there is a Web3 counterpart, right? Thanks Satoshi Nakamoto, is him or her, I don't know, and when he or she is born, I don't know. But thanks to his great invention, right? So we have Bitcoin, and for the first time, we have a way of using cryptography and incentives to have a trust minimization system. And what this entail is that, and people usually call this concept called digital sovereignty, right? So I will be, despite we're still very early, I would say thanks for his invention, we have this booming Web3 economy, right? So that's a history analogy here. So you might say, hey, what's this to do with privacy? So again, as a history nerd, I will remind you these two great gentlemen, Samuel Warren and Louis Brandeis, right? About like 1.3 century ago, and they bring this great idea called the right to privacy, right? Hugely influence the entire civilization, right? So you know what I'm going to ask next, right? The next question is, what is a Web3 counterpart? And here is my personal belief, right? We cannot achieve so-called digital sovereignty without on-chain privacy. And the reason is plainly simple, right? If you think about what is intuitively the digital sovereignty, you should have the right to what and when and how to disclose the data, the most precious piece nowadays, to the world, right? It's such a simple concept and such intuitive. And I don't think we can bring the Web3 to 1 billion users without privacy, right? So let's, again, I'm a history nerd. Of course, I'm a technical nerd too, right? So let's revisit what cryptography empower us, right? So there's a simple truth lies into cryptography is that knowledge is power. Like, why do I say that? If you're thinking from first principle from the cryptographic principles, right? What makes you a sovereign identity different from others is that every single of us have a different private key, right? And this is a fundamental difference. You can distinguish one another from on-chain, right? And because you have a private key and you can sign a piece of transaction, then that's a foundational building block for the cryptography, the public key infrastructure, and also as well as blockchain, right? So here, if you think about what's the future of Web3 and the digital economy, right? You can see almost every public part have a private counterpart. And we can truly reach the booming of the Web3 economy only if we can realize all the private counterpart to the public part. So for example, right? So if you thinking NFT as art, right? We should allow private connectors. And if you're thinking like a marketplace, there are public marketplace, and we want to have private marketplace for bidders. And if you think like on-chain social connection, then we want to have a private messages. And for government proposals, right? I think there is a reason that several hundred years of democracy, we want to having the governance privately, and you have private voters to against like to want everyone freely express their will, as well as against the voter retaliation. And think about the future of work, which is DAO. And it's hard to imagine in any kind of organizations, you have a completely public payroll system, right? So payroll is such a fundamental building block of the future Web3 economy actually require privacy. Last but not least, right? So thinking about games, right? If you look at the interesting games, if you want game have completely on-chain, and there is a game theoretical categorization of game, which is the incomplete information game. Many of the games, for example, Magic the Gathering and like Werewolf, you name it, right? So are like a incomplete information game. And if you have every single cards of the players disclosed on chain, that's just like huge math opportunity for miners, right? So here, that's why I draw this conclusion, right? So privacy is more than just personal freedom. It's actually a requirement if we want to get Web3 to 1 billion users and required at most applications, if you think about that. So, okay, I hopefully I motivated enough for why we want privacy. And next, I'm going to talk about the road to privacy. First, let's look at the Web3 right now, right? So like I showed before, despite we have private keys, and the problem right now is that your private keys will have a deterministic mapping to a public address. And people call this a pseudo anonymity, right? And you are using the same piece of public address to do the DeFi, to do your favorite trading, CL farming, and buy your favorite NFTs, and join many like DAO activities, right? And to make things worse, this public address is public viewable on-chain. And you just need to open your favorite blockchain explorer, for example, Etherscan. You have the entire track record of your public address, right? And what makes things worse is that there are many websites allowed to display your favorite NFTs as your PFPs. And this is directly leaks the linkage of your identity and with your public addresses, right? So despite knowledge power, despite you have a private key, right? What in the Web3 today, right? This is just like a huge privacy leakage for everyone. And to make things worse, if we believe the Web3 space is here to stay, which I believe many of us here believe so, and this transaction history will be on-chain and immutable forever, which means your grandson, your granddaughter can still see your on-chain transactions. I'm not sure you want that, right? So I think, so what can we do here? Basically, we want a paradigm change here, right? We want to have a mapping from private keys to private users, to private accounts, to private addresses. So that's why. So at Poseidon Lab, through like almost 2 years research, we're bringing you the concept called ZK asset. And ZK asset is a flexible and interoperable private asset. So let me tell you what is a ZK asset, right? So just take a step back a little bit, right? So basically, this is, if you go back to the first private cryptocurrency namely Zcash, right? So they have this great idea is that we can have blockchain transactions shielded by zero-knowledge proofs. And how does it work, right? Instead of having an account model, which now is very popular and Ethereum uses, for example, Zcash styled private transactions using a different model called the UTXO model, right? So within the UTXO model, you don't have an entire account. but you have different coins. And different from Bitcoin, from Zcash UTXO model, it actually using private UTXOs. So what does it even mean? So private UTXOs precisely means in a single UTXO, you're not storing the public coin. You're storing a commitment. And commitment, this is a cryptographic commitment, so it's hiding, right? You are committing the asset inside of commitment. And from outside point of view, it's completely encrypted. And now you say, hey, it's encrypted. How can I verify the validity of the transactions on chain? And here comes zero-knowledge proof, right? So whenever you submit a transaction from the asset transfer on chain, instead of submitting a plain text transaction, you submit a zero-knowledge proof. And zero-knowledge proof inside, they open the commitment and also prove that the two output coins have the exactly same balance of two input coins, right? So then you don't have double spending. Also, you have private transactions, right? For the ZK asset we're bringing to the table, we kind of generalize the concept, right? We are generalizing this concept in 4 different ways. So the first is that instead of compare with the original Zcash, it has a single asset, which is public Zcash coin. We have flexible asset types. And more specifically, we support 3 kinds of assets. The first kind is fungible tokens, aka something like ERC20. The second is non-fungible tokens, for example, ERC721 and ERC1155. The last one is non-fungible and non-transferable tokens, aka soul-bound tokens, right? So the second feature is that this asset is private by default. And what does that mean? Private by default, which means that none of your private account, aka ZK address, I will introduce later, is ever leaked on chain, right? You never review your address on chain. So third, it's a disclosing at a well. Again, I will introduce that in more detail, but it's basically give you the power to disclosing your asset holdings in whatever way you specify, right? Last is that configurable asset policy, which means that it allows asset issuers to having some permission control, KYC, regulation compliance, you name it, right? So these are the 4 features of the ZK asset. So let me dive into it. So before I tell you all about ZK assets, let me first tell you ZK address. So this is basically, we call it a PKI, which is public key infrastructure for ZK assets. So fundamentally, from the first principle, we designed this new address system. So first, you have a ZK address. This is analogy to your public address or the 0x address you have in Ethereum, right? And this address is generated by your spending secret. And at the same time, when you are generating a ZK address, you're also generating a viewing key, right? So basically, you have 2 secret keys, one spending key and one viewing key. And spending key allows you to transfer the asset, and the viewing keys allows you to inspect and audit the asset. So thinking of if you're running a company and you want some department having, despite you want to have someone control the spending keys, you want to have another party or your accounting team holding the viewing keys, right? And thinking if you are sort of individual and you want to report your tax to IRS, right? So you can disclose your viewing key to IRS to have a regulation compliance in the cryptocurrency world. And also, so the ZK address itself is private. However, you could publicly share the ZK address to anyone else because this ZK address will not ever be in on-chain, right? So every one of your friends, if you're artists, you can share the ZK address in your website. So otherwise, so other people can send in their crypto asset to you, right? So that's about ZK address. We talk about the disclosure, right? So let me tell you how we are doing the ZK assets to do the asset disclosure. So the asset disclosure itself are actually due and enforced by zero-knowledge proof. So let me give you 2 concrete examples, right? So first kind of asset disclosure we have is called ETH-NFT, right? So now you basically have an input of UTXO, which is a private coin, and also the zero-knowledge proof, right? And also address. For example, you can disclose in something, hey, like I'm holding this ape, but I don't disclose which ape I'm holding, right? So you kind of have this anonymity among the small group. The second kind of asset disclosure we call it at least. Basically, this is for fungible asset, right? For example, you can disclose that, hey, I'm at least, or this particular UTXO at least hold like 5 rep ETH. So you can see, right, these kind of primitives give you a powerful construction if you are doing something more powerful, for example, anonymous voting, for example, something like a quadratic funding scheme, right? So that's a configurable asset disclosure. So now let me tell you the next building block, which is now we have the Zk asset, right? So then we want to implement the most fundamental part, which is the transportation layer. We want, this is the most fundamental and the first building block we're building, and we almost finished building that. So the first protocol I will introduce is Manta Pay, which is a transportation layer for the Zk asset. We're building this in Polkadot ecosystem, right? So Polkadot ecosystem is this very amazing technical construction. You have a layered blockchains. So first you have a relay chain, which is Polkadot Kusama. And this is a relay chain infrastructure kind of building as a public good for security. The second layer you have is heterogeneous solvent parachains. And Manta and Calamari is one of them, right? So the idea here is that each individual heterogeneous solvent parachain doesn't have to be worried about security, and the security is provided by the relay chain. And this is very similar to, like, for example, application-specific chain idea. And last but not least, we have XCM, which is a cross-chain messaging mechanism between different parachains and bridges to the outside ecosystem, right? So here, right? So Manta Pay is building kind of, you can think of Manta Pay as this kind of like a black box or this like module that bridges the public account and public asset in the Polkadot ecosystem to Zk asset, right? And what different here is that we allow the private asset that can natively composable with the public account. So what does that mean? So for example, right? So suppose you have any kind of crypto asset in the Polkadot and Kusama ecosystem, and it could be any Polkadot and Kusama native asset, or it could be any kind of a bridge asset bridged by like cross-chain bridges such as Accelerator or Wormhole, right? So you just need to interact with Manta DApp, and because we have XCM cross-chain connections connected almost to all the major Polkadot parachains, right? You can freely convert your asset to Zk asset, no matter your asset is fungible tokens or NFTs. So let's take a step slightly deeper to see how it works, right? So we're building this Manta Pay. It's a protocol as well as a palette. Palette is, you can think of kind of a code module that inside of Manta parachain. And this module basically has 2 parts. The first part is a UTXO storage system, right? It has a private UTXO storage system. And also we did a lot of innovation inside of the storage designs so that we optimize for sharded storage. And this gives you concurrency. And it also, thanks to the UTXO model, you actually have better concurrency in the account system. And the second module is inside of Manta Pay, there is a ZKP verifier. And this ZKP verifiers verify this unified circuit for both fungible token, NFTs, and soulbound tokens. So one thing that was mentioned here is that we did a lot of no-level cryptographic optimizations. So for example, we're actually having the fastest Gross16 Poseidon hash implementation across the entire space. And as a result, for example, in current Manta or Calamari, the zero-knowledge proof generation speed is only 2 seconds, right? Which adds almost 0 friction to user experiences. And it's about like 10 times faster than original Zcash. And let's take a step slightly deeper to see how can we design the Manta Pay in a modular way. So the entire idea here is that the Manta Pay is actually it's not an asset issuer, but it's an asset agnostic module. So it supports almost all the fungible interfaces. For example, it supports ERC20 or XC20. You can issue in A star or Moonbeam. It supports NFTs. It also supports Polkadot native asset, for example, the asset kind of minted by the pilot asset. It working as an asset agnostic module to give you ZK asset and privacy. So, and thanks to the interoperability and composability brings by the native cross parachain communication mechanism XCM, right? So Manta is able to talk to all the major parachains. Just give you a few examples, like A star, like Moonbeam, like Akala, like Interlay, right? So, and one thing is crucial for the XCM is that XCM is not only a kind of asset bridge, right? It's more like RPC calls. It truly enables interoperability in the sense that you can have a contract call, for example, in the smart contract parachain like Moonbeam, right? And you can directly invoking Manta as a backend for the privacy services, right? So that's a that's about Manta Pay, right? So we actually have go through 2 versions of testnet, and we deployed the testnet v2 earlier this year. So it has amazing growth, and users love to use our testnet. For example, I just give you a few numbers. It already produced more than 162K private transactions, and also has more than 20K unique ZKP wallet download, right? So we're actually in the process of launching testnet v3 and also the final product next month. This is really exciting. And so that's about Manta Pay. So next, I'm going to show you our research part. Also, a little bit sneak preview was what's going to be next, right? So as we're at the end of finishing building the fundamental transportation layer, right? We're actually going one stack up, and we want to build the programming layer, which is the Turing complete layer. We think the ZK asset is incomplete if the private asset itself is not programmable, right? So what does that mean, right? So we want to using Manta as the privacy infrastructure. We're using the Polkadot XCM and also cross-chain bridge mechanisms to provide programmability to all the smart contract platforms that we are connecting to, right? So think about that. How can we do that, right? So I claim the only way we can achieve that is that we're enabling building decentralized applications that requires composable execution over the ZK asset. So again, right, let me dive into that. So what is ZK asset in the context of programmable private asset? So we think, if you think about the word programmable, we think 2 things, right? So the first dimension of the programmable is that it must be interoperable and programmable by the public programming languages and the public execution, which is here, Solidity, right? And also the second dimension of programmable is that it have to be interact with other zero-knowledge proof circuits and other private constructions, right? So here, our ZK asset design will bring you this 2 dimensions of programmability. So for example, so the ZK asset itself support all the standard assets. For example, ERC20, ERC721, and ERC1155. So on the public programmable side, it will support all the existing Ethereum dApps, for example, like Uniswap, Curve, OpenSea, and you name it, right? As long as these smart contract calls are only on the public asset, only on the standard asset. And the second dimension, it will support interaction with other zero-knowledge proof circuits. So for example, it could be something like a sophomore circuit developed by the PSE group from Ethereum Foundation. It could be like configurable asset disclosure policy developed by players like Expresso, and it could be other ZK attestation protocols and your favorite ZK bridges, right? So again, let me dive slightly deeper to show you how does this work. So for the ZK asset, right? So we have this notion called a shielded pool, right? So shielded pool basically is a technical construction and in charge of this private asset. Compared with existing like private asset system, it has 3 functionalities that you can find nowadays in the existing shielded pool implementation. For example, Zcash. it has a deposit, which means you are converting a public asset into the private UTXOs. It has transfer, which means you transfer the private UTXOs to another Zk address. It also has withdraw, which means you can convert the private asset inside the private UTXO out to a public account. So what makes it different is the third interface, and this interface is call, right? This is an extremely powerful construction. It basically takes an arbitrary smart contract call and makes this smart contract call directly execute on the shielded pool, right? So how does this work? So again, we needed to have a little bit generalizations in the UTXO. So in the previous slide, I already showed you how does the Zcash style the private transaction works. And now I want to, from the Zk asset, for the Zk asset implementation, we slightly generalize the private UTXO to a new notion we call the transparent UTXOs. So what does the transparent UTXO work? So the idea here is that you keep the private part, which is cryptographic commitment, the same, and you have a public part, right? So this public part is mutable and can only mutable by the consensus. So what this empowers you is that you can do a private transfer from the pub you can do a private transfer same as before, guarded by zero-knowledge proofs. However, you can transfer this fully private UTXO to this transparent UTXO. You may say, like this balance is public. Does that leak of privacy? The answer is no, right? Because thinking of this public asset, public balances can be only modified by consensus. And because we put this transparent UTXO back to a shielded pool, you can have another spend, right? When you do another spend, it's still shielded by the zero-knowledge proof, right? Despite, so from the, again, you're not leaking any address, public address or Zk address here. So from the observer point of view, you can only observe that in the shielded pool, there exists such a, like a transparent UTXO, right? So now you can see by enable this slightly generalized notion of UTXO, so we can do these cool things. Basically wrapping existing contract calls to private contract calls, right? So let me show you how does it work. So let's say you have some private assets in the Zk asset shielded pool. So without loss of generality, you have, for example, 10 wrapped ETH, which is wrapped in this transparent UTXO in the private part. So what you first do is you do a spend. You spend this 10 wrapped ETH from the private UTXO to the transparent part. And then you kind of delegate these 10 wrapped ETH to a rotor contract. And this rotor contract is stateless, right? Now this rotor contracts kind of delegate and own the 10 wrapped ETH you have. Instead of you calling the Uniswap swap, and this rotor contract calls Uniswap swap. And the result of this contract execution is that let's say you exchange 1 wrapped ETH to 2,000 DAI, right? And now in this rotor contract, it contains like 10 wrapped ETH and 2,000 DAI, right? You write this back as a transparent UTXO, and because you are providing the zero-knowledge proof, and these two transparent UTXO can only spend by you, right? So you're kind of writing using some like a programming language term is side effect, right? As long as a smart contract call, the only side effect is on the standard asset. You can write it back as a transparent UTXO, and then through your asset, this asset is only spendable by you, right? So this is in the high level, how can we achieve like private smart contract calls without changing existing smart contract code, right? So that's about the next primitive we're going to build, right? So I think that's about the talk here. Let me end the talk for my personal belief, right? So we think the privacy is essential to build a network state. So it can and will be achieved. And also, last but not least, we're very, very happy and we are glad to invite you to join us in the journey. And we're Poseidon Labs. We're actually here in the city, and we're hiring like talent from different different jobs like full stack, applied cryptography, backend, business development, and more. Yeah, I think that's about the talk. Thank you.